All right, so we're finishing up 7-1. So this is 7-1, part 3, and then we're going to move into 7-2. So the last 4 questions, we're talking about domain. And we have to talk about domain kind of separately here with how to say radicals and whatnot and rational exponents, just because each one kind of behaves differently. Okay. So we have 3 different ones here. We have the square root, we have cube root, and we have fourth root. Okay. C and A are pretty much the same. So when we are talking about the domain of a square root function, okay, before I told you we could take the square root of a negative number, all right? What couldn't we take the square root of? It's a redundant answer. That we could not take the square root of what to a negative number. So the domain of a square root function on a coordinate plane is all positive values, all numbers greater than or equal to 0. And let me show that to you. All right, so if I have a graphing calculator here and it loads up and I type it in, let's see, it always takes so long. All right. So if I type in a square root function, just a simple one, the square root of x, we can see that it stops right here at 0. Does everybody see that? Meaning we can't take the square root of a negative number on the calculator. Okay, this is all about on the calculator. So if I look at A, okay, the domain of A is going to be this. It's going to be when 2x minus 1 is greater than or equal to 0. Okay? Because we can't take the square root of a negative number on the calculator. Okay? Yes, Lance, it does exist. I can find the square root of it. But when I'm talking about domain and range, we're talking about on a coordinate plane, which only has positive and negative numbers. Agreed? It doesn't have these imaginary numbers. So we have 2x minus 1, and it's greater than or equal to 0. So here, I'm going to go ahead and add 1 to both sides. Okay, and that's going to give me 2x is greater than or equal to 1. And then I divide by 2. And I have x is greater than or equal to 1/2. So I have that, and I can check my work here, Lance, if I type it into my calculator and I type in 2x minus 1, and I'm taking the square root of that. All right, do you see how my graph stops right here, Lance? That's 1/2, okay? If I go to my table, okay, see at 0, it says error. See how 1 was defined and 0 wasn't? Why is that? Because 1/2 occurs between those two numbers. That's why it's undefined. Make sense? All right. Now, let's tackle C while we're at it. Here with C, it's going to be, well, when is 2x squared plus 3 greater than or equal to 0? So I'm going to subtract 3 here. And I have 2x squared is greater than or equal to -3. Divide by 2. And I have x squared is greater than or equal to 3/2. But wait a second. X squared, Chris, what type of number is that? X squared. So let's think of like when you square a number, you get a number out, right? What type of number is that? All right. What if I were to say like, okay, positive number. That's what I want. It's a positive number, okay? So any number I put in for x, it's always going to be positive, right? So this is always going to be true. Whereas like in this one up here, Chris, you know how we got like a definitive answer, like, oh, x had to be greater than 1/2. Here, no matter what I put in, it's going to exist. So let's see what that looks like. So here was what? The square root of 2x squared. And then what? Plus 3. See how it exists everywhere? Positive and negative sides. So when I was solving it, I set it up the same way, but I got to a point where it says x squared needs to be greater than a negative number. It's always going to be greater than a negative number because x squared will always be positive. But now funny things happen with cube roots. And we know this because Kailana, when we were dealing with like the cube root of -8, we got an answer, right? When we took the square root of -8, it was like that imaginary thing. It didn't really exist. All right. So let's type that in, see what happens. Gotta wait for that thing to go away. Let's see. All right. So the cube root was 5x plus 2. So I'm going to go into, let's see, math. Go down to the cube root so you can see I'm actually typing it in. 5x, what, plus 2? Is that what it was? All right. And let's hit graph. All right. Now, yeah, it looks like something you've never seen before. Correct, Kailana? But I don't really care what it looks like. I care that there's values here, okay, in the negative aspect and in the positive aspect. So for the cube root, it's all real numbers. It doesn't really have a restriction, okay? I can take the cube root of a negative number. I can take the cube root of a positive number. So odd powered roots, they're fine. Their answer is all reals. Okay. Even powered roots, Hansi. See how 4 is even? See how 2 is even? They have the restrictions. Okay. Now let's see how the fourth root behaves. So the fourth root type that in, fourth root, nope. Is this going to work? And it was 3x plus 1. And Julia, this is what I do because I don't remember everything. So what I do is I take it and I plug it into my calculator and I hit graph and I look at the graph. Okay. And do you see how in this graph, it's kind of cut off at a number right here, right? So this is going to behave a lot like the x squared. So what I'm after is I'm after finding that number right there, okay? So here in the square root function, we said, oh, we couldn't take the square root of a negative number. Well, we can't take the fourth root of a negative number either. So it needs to be greater than or equal to 0. So I subtract 1. Negative 3x is greater than or equal to -1. Divide by 3 and head. Didn't my answer look like it was just past 0? We go back to that. Doesn't it look like it's just past 0? And doesn't that make sense with what I found? I found it to be -1/3. So you can always use your graphing calculator to kind of like reassure yourself or to give you like an idea of what's going on here. Does that make sense to you guys? You guys see how I used it? I typed in the cube root, saw there was no restrictions. There was a graph going through my whole coordinate plane. So we were good there. And then with the square root, we saw that it was cut off, and as well with the fourth root. So here's what the box says. So the box says this: if n is odd, meaning we have an odd root, the answer is a set of all real numbers. Okay. If n is even, meaning we have an even root, so square root is even because it's 2, fourth root is even because it's 4. It's going to be the set of all non-negative values for what is under the square root. So basically, I take the part that's, I guess, the radicand. I think that's the name of it. the 2x minus 1, and I set it equal to being greater than or equal to 0, and I solve it. Same thing with the fourth root. Make sense to you guys? Kailana? Is this different one than yours? Oh, no, for that one? Okay, so we stopped there. We stopped in C because 2x squared plus 3. Okay, when we were doing that and Chris and I were talking about it, we got to x squared had to be greater than or equal to -3 halves. And we stopped because x squared has to be greater than a negative number. Whenever you square a number, it's always going to be positive. Like -3 squared is 9, right? Anything you square will be positive. Does that make sense? So it's all real numbers. Did I not write that? Oh, my bad. Sorry. All real numbers for C. Okay. Whew. My bad. It's okay. I'm gonna go home, cry myself to sleep like last night. I was really tired. I ran 7 miles the other day. Really tired. It was fun. You see a lot of crazy things in Aston. A lot of crazy things. All right, let's start 7-2. All right, so 7-2 is all about simplifying exponents and radicals with variables. Okay, so we kind of started this in 7-1 when I was talking about like writing those radicals as like rational exponents. So when we're being asked to do this stuff, okay, what I like to do is I like to convert everything into rational exponents. So the 7th root of 2 to the 7, I'm just going to rotate that up to 2 to the 7 over 7. 7 divided by 7 is 1, so that's 2 to the first, which is just 2. Kaylin, are you okay with that? With the 4th root of x to the 4th, I'm just going to rotate that up. I'm going to write that as x to the 4 over 4. And that's just x to the first, which is just x. All right, do you guys see that? And that's how I'm going to go about tackling these problems. Okay? So what I'm going to do with all these problems, all these square root things, is make them all rational exponents. All right? And what that's going to allow me to do, Cody, because I know you missed a little bit of this, it's going to allow me to simplify these problems pretty quickly. All right? So first thing I'm going to do, I'm going to take it and I have to make a rational exponent for the 125 and the 6. So Cody, what I was teaching is you take your thumb, you put it on that number outside the radical, and your pointer finger will go on the exponent of, I guess, the number or the variable, and you just rotate it up. So this becomes 125 to the 1/3. Do you see that, Cody? And then the y becomes, right, 6 over 3. So the power of 125 is 1. Remember, when there's not an exponent there, it's understood to be 1. Does that make sense? So like, this is x to the what power? So they're the same thing. The 125? The 125 doesn't. The y does. Okay? So 125 to the 1/3. This is where your calculator comes in handy. So everybody type in 125 caret 1/3. All right. You should get a whole number. 1 divided by 3. You guys get 5? Yeah. All right. So you're going to get 5 there. Jay Patel. Jay Patel?
Yes.
What is 6 divided by 3?
2.
Problem's done. That's it. 6 divided by 3 is 2. Done. All right. More complicated, number 2. Does everybody see that? Would you agree number 2 is more complicated than number 1? Not really. Ready for this, Hanzi? Yeah. So it becomes 8 to the 1/3, r to the 3 over 3, s to the 5 over 3, t to the 10 over 3. And this says radicals, no denominator. Okay. So they want us to get rid of the denominators, not any restrictions to this stuff. Okay. So assume all variables are positive. All right. So 8 to the 1/3, 2. R to the 3 over 3. 3 divided by 3 is 1. So it's R to the first. 5 over 3. Okay. How many times does 3 go into 5? 1. So I'm going to write S. Hold on to this. All right. Hold on to that piece of info. How many times does T or 3 go into the 10? Now, we had some remainders, right, Hanzi and Nikki Grantland? So I could take the cube root. We had s squared because we had 2 left over, and t to the first because we had 1 left over. Problem's done. You guys see where I got that from? All right, I put my remainders in the house. Carlana, you okay with that? 3 went into 5 one time. That came out. There were 2 left over. That's why it's 2. Okay? And we were taking cube roots. Okay? For number 3, even better. Big fan of this one. Why? I just distribute that 1/4. 625 to the 1/4. J, 8 times 1/4. You guys know what that is?
1.25.
2. Because we would do 8 times 1 is 8 divided by 4 is 2. K to the what power? 1. So all I need to do is figure out what is the 4th root of 625. And you're going to start to get a feeling. Okay, like 625. What is it? 5. So, Lee, you doing okay with this stuff? Not too tricky? Cody? All right. It's because you're out. All right. So Cody, what we can do with radicals and exponents is we can transfer back and forth between them. All right. When it's in radical form, meaning like number 2, okay, we can make the exponents, all right, for each term as like a fraction, okay? So the way we do that is this, Cody. Do you see the s, how the exponent of s is 5? And do you see how that is 3? So I'm taking the cube root. So what I did is I kind of like came up with this thing. It's like right-hand rule or something. You put your pointer finger on the 5 and your thumb on the 3. Do you see that? And I just rotate it up. All right. Why not left hand? Because like it just yeah. So follow me here. So now I just divide these. Okay. 8 to the 1/3. You type that in your calculator. Okay. If you type in 8 caret parenthesis 1/3 parenthesis, it's going to spit out 2. Make sense? R. 3 divided by 3 is 1. 5/3. How many times does 3 go into 5? 1 time with 2 left over. So 1 s came out and the 2 stayed inside. Make sense? But we're talking about a cube root. right? So that's why it's still a cube root of s squared. 3 went into 10 3 times with 1 left over. So that's why it was the cube root of t to the first. Here, with a power raised to a power, we distribute that 1/4. So the 1/4 goes to the 625. The 1/4 goes to the 8. What is 1/4 of 8? Well, we would do 8 times 1/4. So we do 8 times 1, that's 8, divided by 4, 2. That's where that came from. What is 1/4 of 4? Well, that's 1. So it became 625, type that in. I got 5, j squared k. A little bit better? All right, we'll keep working on it. Here, we have a lot of things going on in number 4. Julia, we have numbers, we have x's, we have y's, and we have z's. The directions say simplifying rational exponents and radicals, no denominator. We don't want denominators, okay? So that means I have to make this a not a fraction, okay? So what I'm going to do here is I'm going to kind of like break it apart, all right? First thing, 6 divided by 2, 3. Now, I have to figure out, what do I do when I divide powers? Julia, do you remember? We subtract. So the exponent to x is 1. So I have 1 minus 1/3. 2/3. And since it's positive, it's up top. All right. Now I have y to the 1/2, right? Nothing I can do with that. It's just y to the 1/2. Are you all right? So far, so good?
How did you get?
We subtract the exponents. 1 minus 1/3, 2/3. You okay?
Yeah.
Now, z to the -5th. If you recall, when it has a negative exponent, it's not where it belongs. Okay? So z to the -5th, it's not where it's supposed to be. It's down in the denominator, so it needs to go to the numerator. So there we have it. Now, why did I not write it, I guess, like number 2? Well, I can't really combine like cube roots and square roots nicely. Like here, everything was a cube root. That was nice. It was easy to deal with. So I kind of left it like that. With number 4, I'm going to leave it like this as rational exponents. Okay? Any questions with that? Chris? No questions? Lance? Jake? You're scratching your head.
Yeah, how did you get the 1/2?
1/2, right there.
Oh, okay, you just brought it down.
And then, yeah, nothing I can do with it.
But how did the -5 become positive?
Z to the -5th. A negative exponent means it's not where it's supposed to be, Jake.
Oh,
Technically, it means 1 over z to the 5th. But when I kind of have it in a fraction, it's in the denominator. Like something divided by a fraction. Remember, you multiply by the reciprocal. So we're kind of multiplying by the reciprocal, but that's really complicated and convoluted, right? So what I like to think of is every problem I do in math is like a fraction, whether it's written as a fraction or not. When I'm dealing with exponents, if I have a negative exponent in the numerator, well, it means it's not where it's supposed to be,
yeah.
right? Because it has a negative exponent. So if it's in the numerator, I've got to put it in the denominator. Likewise, if I have a negative exponent in the denominator, well, it's not where it's supposed to be, so it needs to go to the
So
numerator.
you flipped it.
I flipped it. Okay? So I'd leave it like that. Any questions? No? All right. Let's look at number 5. Lance, what would you do for number 5? All right, so tell me what to write. Mhm. All right. What is the fourth root of 64? You got a root, right? Yeah, like a big decimal. All right, so not a problem. The fourth root means we're looking for groups of 4, right? So you said 2 came out, right? So let's break it down by 2s. 64 divided by 2 is, break it down by 2. All right, so 16 and 2, break it down by 2. 2. All right, so we got a whole bunch of 2s, right, Lance? But I need groups of 4. So I have 1, 2, 3, 4. So I have 4. So 1, 2 comes out. Okay. How many are going to be left in? 2. Okay. So here's what's kind of going on here. I have stuff that's going to come outside the house, and I'm going to have stuff that's left in the house. I tried doing it the short way by plugging it in my calculator. It didn't totally help, but it did tell us 2 went into it. So what I did is I pulled that 2 out. It's going to go here. There's 2 2s left over. 2 squared. You follow me here? Now, d to the 4 over 4. What's 4 divided by 4? 1. So 1d comes out. E. How many times does 4 go into 9? Twice. With how many left over? 1. So that E goes inside. F. 3 times. With how much left over? There's your answer. All right. You okay with that? All right. Kailana? I know it's a lot. Kind of. The what? This? Yeah, it's the 4th root. So I just kept it. If it was like, what do you mean if there was no 4th? Yeah, if it was doing the square root of 2. Yeah, if this was 2, we would have been fine because the square root of 64 would have been 8. So we would have been good.
Yeah, that
What?
messed me up. Like, where is it? Your 4 group of 2, not just.
Oh, this? All right. So when we take roots of numbers, okay, I like to think of it as prime factorization. All right. But the root, like square root means 2, right? Make sense? Square 2, right? Make sense? Like the exponent x squared is 2. So when we take the square root, we're looking for pairs of numbers. Cube root. Cube means 3. So we're looking for groups of 3. 4th root, we're looking for groups of 4. So when I'm looking for, because Lance typed it in, he got this weird decimal, right? But we need to simplify it somehow. So if I break down 64, I'm looking for a number that is repeated 4 times. So when Lance did it, when he typed in 64 to the 1/4, he got 2 point something, right? So you got like 2 point something. So I said, all right, well, let's see 2. So we did 2 goes into 64 32 times, okay? And then I was like, okay, well, I need groups of 4. So let me try to break down into 2 again. So I did 32, 16 and 2. Make sense? Because it's the 4th root. No. If it doesn't work out. Or you could remember that like, oh, 16 is the 4th root. Fourth root of 16 is
I'm
2.
remembering that.
I like to break it down into like, oh, let me just find groups of, 5, 4, whatever. Like, this is way more concrete than memorizing more stuff. Like, oh, fourth root, let me just look for groups of 4. Fifth root, let me look for groups of 5. No big deal. Number 6.
I still love the fact stuff goes outside, stuff goes inside.
Well, stuff that goes outside means like the group. Look, I have a group of 2s. That 2 came outside because I had a group of 2s. These guys didn't have any friends. They were a pair. You need 4 people to make a group there. They only had 2, so they had to stay inside. All right, it's kind of like the buddy system.
Why is that D out?
Why? 4 divided by 4. There were 4 Ds. 4 divided by 4 is 1. Came outside. 9 divided by 4. Well, it goes in 2 times with 1 left over. 4 goes into 14 3 times with 2 left over. Here, how many times does 5 go into 15? Well, I'm kind of viewing this as a fraction. Okay. So 15 divided by 5 is 3. Now, D squared and D. Well, we subtract these, right? The exponent of D earlier, Nikki told me it was 1. So I'm doing 2 minus 1. That's 1. E says 2/3. There's no other E's there. Now let's look at F. We have 1 minus -4. Minus a negative means what, Jake? Minus a negative is a positive. So 1 plus 4 is? Yeah. So that's my answer. So 3, D, E to the 2/3, F to the 5th. All right, number 7. All right, we're just going to rotate this up. Ready, Hansi? So 4 and 4. So it's going to be x to the 4 over 4. You see that? Y to the 8 over 4. Got it? What's 4 divided by 4, Hansi? 1. 8 divided by 4.
8 divided by 4, 2.
We have x over y squared. Easy enough? Sure, no denominator. Knew you'd see that. So, no denominator. There you go. Yeah, because it just means, hey, y is supposed to be on bottom, so if I want it on top, I just give it a negative exponent. All right, number 8, last one for the day. Rotate it up, x to the 1/3. Y to the 7/3. Well, x to the 1/3, not much I can do. All right, now this is where it gets kind of tricky. Here, 3 goes into 7 2 times with 1 left over. Now,
Well, why don't we use that other?
oh, you want to do it y to the, oh, we could. Right. No, that's okay. I want to do it though. What? That thing? What box? Yeah, so that's what I was going to get to. But if we want to write it, because we're going to run out of time here. I know, what a shame. So we're going to have x to the 1/3, but the 7/3 is down bottom. And Hansi's going to be like, well, we can't write it with the denominator. So we can write it as -7/3, okay, and go from there. I'm going to talk more about how to deal with this stuff here.
So it's not done.
I mean, technically by the directions it's there, it's done, but
That's what I would have.